and deepen our understanding of the principles of artificial intelligence. There's just so much that we need to learn. But there are also many practical issues that I hope some of you will be motivated and inspired by today's conference to pursue. On the previous slide, I had a beautiful artwork, and I'll show it again here. This is a beautiful artwork by a man named William Morris, who worked in the late 19th century. And he was the leader of a movement in Europe called the Arts and Crafts movement. William Morris was very interesting because he believed that all people everywhere should have access to beautiful objects in their own homes. And so he led a movement of artisans to create and disseminate access to beautiful objects for the home. And this is one example of a design that William Morris had developed. And while the principle of universal access to beautiful objects was very beautiful, in fact, creating such beauty required such skill, such craftsmanship, and such devotion that, in fact, the number of artisans that were capable of creating such beautiful works was very small. And because of that limitation, in fact, such beautiful artifacts for the home ended up being only for the privileged few because of how expensive they were. Well, today, our current state of knowledge of artificial intelligence similarly requires tremendous craftsmanship. And it's a craftsmanship and a skill that very few people, not enough people, have access to. And so when you come to China, you see a rich tradition of artisans, a rich history that's unrivaled anywhere in the world. Artisans working in bronze, in silk, in jade, in ceramics, and actually countless other media. And so a second hope that I have for the conference today is that some of you might be inspired to become the artisans of a new era. Artisans that have the craftsmanship and skill to harness big data, to create and mobilize the kind of massive computing infrastructure that artificial intelligence needs. Artisans that have the mastery of the algorithmic foundations and the scientific foundations of artificial intelligence, and that together, by working together, we can create an artificial intelligence that is truly available to everyone. And so this is our goal. Today, however, we are not in an industrialized process of artificial intelligence. We are really in an artisanal process that requires a great deal of skill. And what is it involving? Well, for the most part today, artificial intelligence is based on an idea of machine learning. And as a scientific discipline, machine learning is simply the study of machines that improve with experience. And in the era of big data that we live in today, experience equates simply to data. And so what does this look like? Well, we can have a computer system that has a special type of algorithm for machine learning. We can create what's called training data. So let's imagine that we want to train a computer to understand and recognize speech. We can record many small recordings of people speaking, and then use human intelligence to label each recording with a transcript of what's being said. So here we have a picture of a short recording of someone saying, "Hello, how are you?" And then from that label, we can take many other samples, actually maybe thousands or even millions of such samples, employ a great deal of human intelligence to label them, and then feed all of those things into the machine learning system. The result of machine learning is to produce what's called a model. And today the models are based on an idea called neural nets, or convolutional neural nets, deep neural nets. And overall, this is sometimes referred to in the literature as deep learning. The wonderful thing about the models is that while the machine learning process itself might require very large amounts of data and an extremely large amount of computing power in order to generate the model itself is oftentimes